This is Ethan Monk, Head of Product Development at Lucid TC. And today we're going to walk through the process of using the TwinGraph SDK MCP server along with the Google Gemini CLI to quickly create a digital twin and publish it to a Neo4j graph data store for persistence and future processing. So for those of you not familiar with TwinGraph SDK, TwinGraph SDK is a tool set to define, deploy, manage, and orchestrate graph-based in-memory and persistent digital twins. So with that said, let's get started. First off, as you can see on my screen here, is a product specification sheet for a fictitious product called the Optipower Management System, or OPMS. So we can scroll through this document and see there's quite a bit of information here, right? Looks like there's some pretty cool features. Looks like it supports MQTT. That's awesome. It has intelligent environmental sensing. Also very cool. And there's quite a bit of technical specs embedded in this doc. So before we get to the Gemini CLI, I want to pull up our local Neo4j graph database here. So as you can see, right now nothing's coming up, but the end goal of what we're trying to do is to get Gemini to use TwinGraph SDK to create this digital twin. And when it does so, those digital twins, or twin graphs, as we call them, initially exist in memory. But we're also going to take that twin graph and publish it to Neo4j, again, for persistence and future processing, maybe via other team members, or maybe we want to iterate this and we just want to be able to pull this down into other workflows for in-memory processes. So let's now take a look at the Gemini CLI. Now you can see we have a prompt here, but before diving into that, I want to point out a few things. One, you can see we have one MCP server configured with Gemini CLI. That is the TwinGraph SDK MCP server. And the purpose of this MCP server is to give access to Gemini or any other LLM to be able to actually use the tools and use the functionalities available in TwinGraph SDK directly. So instead of us having to go write that code, if we want, we can just ask an LLM, in this case Gemini 2.5 Pro, to do that for us. I should also note we're using Gemini CLI in this example, but you can really use anything you want. A lot of people use Cloud Code, there's LibreChat, there's you can create your own AI agent with this MCP server. That's up to you, but this example is with the Gemini CLI. So now let's dive into this prompt. I'll point out a few things. First off, we are referencing this Optipower Management System spec stock. Again, that's the specifications document we just looked at for the fictitious product. Next, we're asking Gemini to create a twin graph with the twin graph ID of myQuickTwinGraph. And finally, once the twin graph has been created, we're asking it to publish the twin graph to our local Neo4j graph database. And we included the credentials here in the prompt to allow Gemini to do so. So now before we send this, for curiosity's sake, I'll start this timer and we'll send this prompt off. And I should note that as Gemini is getting ramped up here, it's going to ask us to approve its access to these TwinGraph SDK tools. And you can do that all at once if you want. You don't have to do that manually like we're going to in this demonstration. But for demo's sake, I think it's nice to actually see everything that Gemini or the LLM is actually doing in this case, kind of manually. It makes it fun. So as I stated, we're just going to keep pressing yes, allow once. You can see you could also press 3 or 2 or 4, depending on what you're trying to do. Okay, and now we can see in well under 5 minutes, Gemini has created and configured the twin graph, including nodes and MQTT, and published it to our Neo4j database. The process is complete. So let's take a look and query our Neo4j database to see the results. Okay, so before summarizing what happened, just a quick explanation of this TwinGraph or TwinGraph digital twin that we're looking at, right? We have this base node. We have, in this case, a graph data store Neo4j node, which is actually represents the database we're looking at right now. It represents that connection as an integral part of this digital twin because that's a graph database that it gets pushed to and it can also pull from. We also have this MQTT broker node with MQTT topics. And these, again, especially in memory processes, would actually handle the data ingestion and publishing too, in this case, regarding an MQTT broker. So if we're streaming telemetry to this digital twin in memory, the data is actually feeding through the connections embedded via these MQTT brokers and subscriptions. Along with these, you see, we actually have quite a few other node types, all based on the specifications in that product spec sheet. We have a power monitor, an environmental sensor, a managed outlet, and a couple others. Now, all of those have their own data embedded onto this node based off the specifications and their own relationships throughout this graph that represent this fictitious product. So this gives us a really good starting point, right? We go from zero, or I guess having a product spec sheet, to actually having a digital twin model that's actually running in memory right now too. And it has been published to a Neo4j graph database to persistence. From here, right, this can be iterated upon, whether directly via the SDK or whether continued prompting via the MCP server. It can be pulled into processes for maybe an in-memory simulation. It can be integrated with really anything you want at all. This SDK, TwinGraph SDK, is accessible via Python. So the opportunities are really endless. So to summarize what you just saw is we had a product spec sheet and we used the Gemini CLI to quickly reference that product spec sheet and create a TwinGraph digital twin and publish it to a Neo4j graph database in under 5 minutes. So really excited to hear people's comments, people's questions, and excited for the next demos and showcasing some more of the features available in TwinGraph SDK. Well, thank you very much.